In February 2026, Juno's 81st orbit confirmed something that shouldn't exist. Jupiter has a core. Jupiter doesn't have a core. Both statements are true at the same time. This isn't a sensor glitch. The measurements have been verified for 9 years. What NASA found below Jupiter's clouds broke every model we had for how planets form. And it gets worse. When Juno measures Jupiter's gravity, it's reading the planet's fingerprint. Every variation in speed tells us what's underneath. Dense material speeds the probe up. Lighter material slows it down. It's physics. It can't be faked. For decades, scientists expected one of two answers. Either Jupiter formed from a gas cloud collapse with no core at all, or it built a solid rocky core first, then captured gas around it. The data matches neither. Instead, Juno found a gradient. Heavy elements mixed through half of Jupiter's radius, with no boundary separating them from the lighter hydrogen above. Scientists call it a fuzzy core. Think of it like this. You expect an egg with a clear yolk and white. What you get instead is a latte, where espresso swirls through milk with no clean separation. The question isn't just what this is, it's how something this unstable survived for 4.5 billion years. The obvious answer? Planetary violence. Maybe Jupiter started normal. Solid core, gas envelope, everything textbook. Then another planet-sized object smashed into it early in solar system history. The impact scrambled everything like two eggs hitting at thousands of kilometers per second. Scientists got excited. This could explain the fuzzy core and Jupiter's lopsided magnetic field. So they tested it. Supercomputers ran hundreds of collision simulations, different impact angles, different speeds, different ages of Jupiter when it got hit. Every single simulation failed the same way. Here's the problem. Heavy elements sink. Always. It's thermodynamics. Even after a catastrophic collision scrambles Jupiter's interior, gravity pulls the heavy stuff back down. The models showed this happening within 100 million years. Jupiter's core should have reformed a clear boundary. But Juno's data shows it's still mixed after 4.5 billion years. That's 45 times longer than the settling time. Something is keeping those elements permanently scrambled against every natural force trying to separate them. What could do that? The answer came from Saturn's rings. Scientists noticed the rings vibrating in specific patterns, responding to oscillations deep inside Saturn. It's like studying Earth's interior through earthquakes, except the sensors are ice particles 400,000 kilometers away. When they combined ringwave data with Cassini's gravity measurements, they found something shocking. Saturn has the exact same fuzzy core structure. Two gas giants, identical internal architecture. The odds of two random collisions creating this? Astronomical. This isn't an accident. It's not collision damage. It's something fundamental about how all gas giants form. The textbooks were wrong from page 1. Gas giants don't build themselves in neat layers. During formation, temperature and pressure create stable zones where heavy elements get trapped. They can't sink. They can't fully mix. They just sit there, creating a permanent gradient that defies our intuition. And here's what that means. We've discovered over 4,000 exoplanets. Many are gas giants. We've been modeling every single one of them incorrectly. Wrong core structure means wrong atmosphere predictions, wrong evolution timelines, wrong habitability estimates for their moons. Jupiter didn't just break our model of Jupiter, it broke our model of planetary formation everywhere. Scientists hoped the fuzzy core would explain Jupiter's other mystery, its impossible magnetic field. Jupiter's magnetosphere is the largest structure in the solar system. It extends 1 billion kilometers past Saturn's orbit. Generated by an ocean of metallic hydrogen spinning inside the planet. But the field is wrong. Earth has 2 magnetic poles, north and south. Jupiter has 3. The North Pole is strong and concentrated. The South has a weak pole, plus a second South Pole offset to the side. It's lopsided in a way that shouldn't be stable. When scientists modeled how a fuzzy core would affect the magnetic field, they expected answers. They got more questions. The stable, non-convecting regions that create the fuzzy core should generate completely different magnetic patterns than what Juno measures. Current theory involves helium rain falling through the interior, creating electrical currents that distort the field. But here's the truth. 9 years of data and we still don't fully understand how Jupiter's magnetic field works. The fuzzy core didn't solve the mystery. It made the mystery bigger. If Jupiter formed differently than we thought, that changes how Earth formed. Jupiter's migration through the early solar system distributed heavy elements everywhere. It determined where water condensed. It controlled which materials reached the inner solar system when rocky planets were forming. Understanding Jupiter isn't just about understanding one planet. It's about understanding why Earth has oceans, why Mars lost its atmosphere, why Venus became hell. The Europa Clipper launches in 2030. It will measure Jupiter's gravity from different angles, potentially revealing how deep the fuzzy region extends. Future missions might drop probes into Jupiter's atmosphere, sampling the transition zones directly. But every answer creates 10 new questions. The fuzzy core isn't a weird exception. It's the rule, and we missed it for decades because we never looked carefully enough. Here's the twist nobody expected. Juno was supposed to die in 2018. The mission got extended to 2025. But in February 2026, NASA confirmed Orbit 81 is complete and Juno is still functioning. The radiation belt that was supposed to fry its electronics in 20 months? Juno found a gap in the field during its first approach. It's been threading that needle for 9 years. Nobody knows how long it will last. Eventually, the orbit will decay and Juno will fall into Jupiter's atmosphere. When that happens, it might get closer to the cloud tops than any probe in history. Imagine what it could see in those final moments. Closer to the fuzzy core, deeper into the metallic hydrogen ocean, right into the mechanism generating that impossible magnetic field. NASA hasn't announced when they'll deorbit Juno. Maybe they're waiting to see how long it survives on its own. Because here's what 9 years of impossible data taught us. Jupiter doesn't follow the rules. Not formation rules, not magnetic rules, not survival rules. And Juno? Juno stopped following mission rules the day it arrived. That measurement in 2026 rewrote textbooks. The fuzzy core forced us to rethink 4.5 billion years of planetary evolution. But the real revelation isn't what we found. It's what it cost us. Every model we built for gas giant formation was wrong. Every exoplanet interior we mapped was wrong. Every prediction about how these systems evolve was built on a foundation that doesn't exist. We didn't just discover something new about Jupiter. We discovered that our most fundamental assumptions about how worlds form were fantasies. And Jupiter is still keeping secrets. Somewhere in that fuzzy core, in the swirling gradient between rock and gas, there are mechanisms we haven't even thought to look for. Gravity doesn't lie. But sometimes gravity tells you truths you weren't ready to hear.